Now we'll turn our attention to a part of the resilience conversation that's often invisible: infrastructure. I'm talking about power lines, septic systems, well standards, and all of the underground, out-of-sight systems that Carlisle residents rely on every day. These systems are under real pressure from climate change. In this theme, we've identified three key actions. The first, to address power outages and consider undergrounding power lines. The second, to clarify and strengthen our septic and well regulations. And the third, to explore a town-wide septic system utility. Let's break it down. Carlisle is fully dependent on private wells for water and private septic systems for wastewater. We don't have a municipal water system. We don't have sewer. And when the power goes out, wells stop pumping. On top of that, many homes are far from the grid edge, meaning long utility lines which are vulnerable to falling trees. Our septic regulations are fragmented across multiple codes, and no central system exists to monitor septic failures, upgrades, or risks townwide. As storms grow more intense and droughts more frequent, we need infrastructure that's smarter, stronger, and more transparent. Let's zoom out. Why do these infrastructure vulnerabilities matter? Because when infrastructure fails, it cascades. When power goes out, wells stop pumping, Wi-Fi and cell towers go down, septic systems may back up, and homes can become uninhabitable, especially for seniors or medically vulnerable residents. And this is in a town where 100% of drinking water and wastewater treatment is private and decentralized. If we don't act proactively, climate change will act for us, and the results won't be comfortable. The first action is to assess power line vulnerabilities. Carlisle experiences frequent and widespread power outages due to above-ground wires, overhanging tree limbs, and long single-access roads to homes. We're recommending a mapping and analysis project to identify where outages occur most often, to cross-reference with public safety infrastructure and vulnerable populations, and to explore the strategic undergrounding of power lines. Undergrounding is expensive, we know that. That's why we're focusing on high-priority corridors first. This means emergency access routes, dense clusters of homes, and areas with recurring outages. This is a short to medium-term action depending on funding, but it's already under discussion with the Environmental Sustainability Committee, the local Emergency Planning Committee, and the Department of Public Works. It also aligns with our energy resilience goals, which you'll hear about in Theme 6. The next action is to align the septic and the well codes. Carlisle's septic and well systems are governed by a patchwork of documents, including Board of Health subdivision regulations, zoning bylaws, water supply regulations, wetlands bylaw, and general bylaws. Here's the problem. Development in Carlisle is dependent on private water from individual private on-site wells and private on-site wastewater treatment and disposal through on-site septic systems. This reliance on private on-site wells and septic systems makes groundwater protection and hydrogeology very important in the town of Carlisle. Understandably, town residents and staff are acutely concerned with ensuring that wastewater disposal does not contaminate drinking water and surface waters, and that the drinking water supplies at individual wells remain adequate to support the development that depends on them. Although there appears to be a general and accepted heightened concern for resource protection, the tools used to manage water supply and wastewater management in the local regulations are not as well understood across the community. The community is being asked to make decisions about resilience and adaptation to changing environmental conditions in the face of climate change. And it is increasingly important that the citizens of Carlisle understand the implications of Carlisle's local drinking water and wastewater regulations. A better understanding of the basic science and methodology behind the standards can lead to more informed decisions around development approvals and municipal planning and policy. Why is this important in the realm of climate resilience? Standards that protect the community's water resources into the future can increase the resilience of the community. A community's resilience can also be strengthened by creating opportunities for new and varied housing options, including smaller units that allow an aging population to stay in community and a younger population to enter the housing market. This helps maintain the social fabric of a community. Standards that challenge these housing options also challenge the social resilience of the community. The next action is a big one, to explore a town-wide septic utility. Here's a question. What if Carlisle created a municipal utility, not to own septic systems, but to manage data, inspections, and maintenance tracking across the town? Other Massachusetts towns have done this, especially where private systems dominate. A septic utility can maintain a centralized database of systems. It can send reminders for inspections and pump outs, track upgrades and failures, and identify emerging risks like aging systems near wetlands. This wouldn't mean the town takes over septic systems, it just means we stop flying blind. This idea emerged from stakeholder discussions, and it's a great example of data-supported climate planning. It's a medium to long-term initiative, but we can start small. This could mean piloting with voluntary participation, using GIS tools to map existing systems, and building toward a utility framework over time. As a quick recap of these actions, we can assess power infrastructure, map outages, and explore undergrounding in key areas. We can understand septic and well codes to make better informed decisions. And we can develop a septic system utility to improve oversight, maintenance, and resilience. These might not be flashy, but they're critical. Resilience starts below the surface.